So after looking for non-redundant cover, there is another concept which is called canonical cover or minimal set of functional dependency. Now, what is the meaning of non-redundant cover and what is the meaning of canonical cover? So in the non-redundant cover, we look for any functional dependency which is duplicate. Now here in the canonical cover, we look for non-redundant cover. It means we look for those functional dependency which does not require, as well as means apart from that, we look for some additional things. And what are those additional things? We see for in the determinant part if any attribute is extra, or in the right hand side part is any uh, attribute is extra. So we have to look for those. Are you getting it what I'm saying? So what I'm saying is, like here, we are looking for any functional dependency which is duplicate. It is okay. But in the canonical cover, we look for any anything which is in the right hand side extra. From B and C is anything is extra. From A, E, and H, anything is extra. From A, B, H, anything is extra. From B, D, anything is extra. Do we have any extra attribute here in the left hand side part, in the right hand side part? Additionally, of extra functional dependency, we have to find out extra attribute also, right? So that is called canonical cover. Let's go for it. Set of functional dependencies may be redundant dependencies that can be inferred from the other. For example, A determines C is redundant in A determines B, B determines C. Yes, so we have find out that this is not required. So if we have the functional dependencies like A determines B, B determines C, and A determines C, if we'll find out the non-redundant cover, so this will be removed because this is a duplicate one. Why? Because A determines D, B determines C is A determines C is already there with the rules, inference rule that we have seen. So what I want to tell you is, in the previous questions that we have just solved is talking about redundant functional dependency. This is talking about one step further and says that you have to find out in the left hand side part, do we have any extra, or in the right hand side part, do we have any extra? So the part of the functional dependency may be redundant. It says that part of the functional dependency may be redundant. And what are the part? Maybe the right hand side part. A determines B, B determines C, A determines CD. Can be simplified to A determines B, B determines C, and A determines D. So here C was extra. In the left hand side part also, A determines B, B determines C, AC determines D can be simplified as A determines B, B determines C, and A determines D. So here we find out this attribute is extra. So what are the ways that we can find it out? In the left hand side part, do we have all the minimal cover, or in the right hand side part, do we have all the minimal cover? So for that, we use the concept of canonical cover. The canonical cover of any functional dependency set F is a minimal set of functional dependency equivalent to F, or equivalent to set of functional dependencies having no redundant dependency or redundant part of the dependency. This is the meaning of canonical cover. The meaning of canonical cover is it is a minimal set of functional dependency. It is equivalent to the functional dependency set having no redundant dependency or redundant part of dependency. It means that there will be no duplicate functional dependency exists, as well as the left hand side part and the right hand side part of all the functional dependency will also not be redundant. So let's go for the canonical cover and try to understand how we'll find it out. So this is the logic behind it. to find out the extra attribute in the left hand side part and in the right hand side part. That is called extraneous attribute. So how we'll find out extraneous attribute? Consider a set of functional dependency of functional dependencies, and the functional dependencies are given, let's say alpha determine beta in any functional dependency set. Attribute A is extra or extraneous in alpha, means left hand side part, if A belongs to alpha and F, the functional dependency set, logically implies F minus, or what are the functional dependency set is, will remove this functional dependencies and will add alpha minus A determine beta. It means that we'll remove that particular attribute from the functional dependency set, and we'll see that do we have any extra in the left hand side part. In the same way, we'll go for the extraneous attribute of beta part. Beta part means right hand side part. If A belongs to beta, if A belongs to beta, the set of functional dependencies we have to find it out is F will remove this functional dependency and will add the functional dependency beta minus A, logically it implies F. So in the last example, if you have find it out, what we have done here is to check any functional dependency is extra or not. We assume that that functional dependency doesn't exist. So we think that it is not there temporary. In the same way, to find out any attribute is extra in the left hand side or in the right hand side, we have to think that that attribute doesn't exist. Okay, that attribute doesn't exist. Functional dependency will be there, but that attribute doesn't exist. Implication of the opposite direction is trivial in each of the cases above, since a stronger functional dependency always implies a weaker one. So it want to say that we have to find out the functional dependencies which are the stronger functional dependencies, because with the help of the functional dependency we can find out more functional dependency, as we have seen different inference rule, right? This is also an example, like if we have A determines C and AB determines C. Okay, B is extra in AB determines C, because A determines C and AB determines C logically implies A determines C. That is result of dropping B from AB determines C. Now, if this is the functional dependency set, it is obviously it says that if A is determining C and AB is determining C, let's say roll number is determining the name and roll number plus its branch is determining the name. So if we'll remove the branch, then also alone roll number can determine the name. Yes, which is already there. So why B will be here? So to removing this particular B from this left hand side part, we required one logic. In the same way, if we'll see this example, A determines C, AB determines CD. Now C is extra in AB determines CD, since AB determines C can be inferent even after deleting C, right? Because here if you'll see a particular D is extra here, because A determines C already here. So AB already, AB determines CD here. Particular D is extra. To find it out, we'll use some rules. So it is the example which says that in the left hand side part we can remove, and in the right hand side also we can remove some of the attribute if we find out that attribute is extra. So how we'll find out any attribute which is extra? So for that, this is a rule. Consider a set of functional dependencies, and the functional dependencies alpha determine beta in F. To test if attribute A determine alpha is extraneous in alpha. Getting it? What is saying? There is a functional dependency alpha determine beta. Let's say alpha is consisting of AB and beta is consisting of, let's say, CD. So what is the ultimate functional dependency we have? AB determines CD, right? Now, in this particular part, which is alpha part, in this particular part, which is beta part, in alpha part, let's say we have an attribute A. So definitely A belongs to, or A is a subset of, or A belongs to alpha, right? Because A belongs to AB, right? A is already there. So this exists, and we have to find out that A is extra or not. So finding out A is extra or not, we just compute the rest of the functional dependency. Means so here we have to find out any extra attribute in the left hand side and in the right hand side. So let's talk about the left hand side first. So let's say in this particular part, if we are thinking that any attribute is extra, so we'll just remove that particular attribute and find out the closure using the rest of the dependencies. And we'll check for the rest of the uh, attribute closure contains beta, the beta part. If it does, A is extraneous in alpha. If we'll find beta, it means that A is extra. Now this is for the left hand side part. This is for the left hand side. Now let's check for the right hand side part. We'll check for any attribute A which belongs to left hand side. Beta is extra. So we have to find out the closure of alpha. The alpha, we have to find out the closure of alpha using the dependency. What are the dependency we have to use? We have to use the functional dependencies which are not existing this particular A. And if alpha closure contains A, if it does, A is extraneous in beta. So for both, the condition is different. Here we have to find out that the rest of the part is closure is determining beta, or the left hand side part or the determined part closure is containing that particular attribute which does not will just remove it, then we'll say it is extra. Okay, so for both the condition, to checking it in the left hand side and in the right hand side is different. Okay, so let's see a quick example and try to understand these two. This is the example. Here we have only three attribute, and we have A determine BC, B determine C, A determine B, AB determine C. Okay. Now, what are the steps that we have to follow? Actually, there are three steps that we need to follow. Okay. So the first step is every time we have to look for the three step. First, we have to make a union operation. Second, we'll find out the extra in left hand side. And third, we have to find out extra in right hand side. So these are the steps that we have to follow. We have to perform the union operation. We have to find out extra in left hand side, and then we have to find out extra in right hand side. Okay. Now, if this is the case, means we have A determine BC, B determine C, A determine B, and AB determine C. If we'll see this, can we make a union operation here? Because the determined part is the same, A determine. Can we make a union of these two? We'll make the union of these two. What we'll get? We'll get A determine BC, B determine C, and AB determine C. So what do you understand? We understand that this is of no use. A determine B is of no use, right? We make a union of it. When we make a union of it, we'll have A, B, C union B. So we'll get B. Sorry, BC. BC union B will get BC. Now this is the functional dependency. In this functional dependency, we'll go and check for the left hand side extra or not. So in the left hand side part, if you see, this is the minimal one, right? So there is nothing we have to check. This is also a minimal. We need only one attribute, atomic attribute. This is the two attributes. So we have to check for A and B. So we'll check for A is extra or not. Here in this particular dependency, we have to check A is extra or not. So what we have to do? What is the procedure? The procedure is we have to find out in the left hand side part is extra or not. So we have to compute the closure without using that, and we have to check that closure is getting the beta or not. It means that we have to check B closure without using this, right? And we have to see that whether C is coming or not. So we have to do that without using this particular functional dependency. So you assume that we are not using this particular functional dependency. Now we have to find out B closure. We'll go for B, right? So what is B closure? B will come. We are not using it, right? Rest of the thing we have to use. Now B is determining anything? Yes, B is determining C. So as you see, you are getting C here. So if you are getting C, it means that this A is extra here. This A is extra here. Now, if we find out this A is extra here, so we'll remove A by writing the functional dependency. A determine BC, B determine C, and again B determine C. Because we have removed A, right? We have removed A because A is extra. We find out A is extra. Why? Because we are getting C. See? If you are getting this particular beta, the beta part, it means that this A is extra. And here also we find out that this is the C, the beta part, and we find out in the closure. So we just remove it, and this is my functional dependency. After that, we'll make a union again. If we'll make a union, so these two will be united or make a union of it. So we'll get A determine BC, or I'll write the functional dependency set here. A determine BC and B determines C, because these two are duplicate, right? B determines C, B determines C, will make a union, B and C will come. Now here we have to find out in the right hand side part is anything as extra. For this we doesn't have to check because it is a smaller one, and means we'll not get anything extra here. Here we have to check. So we'll check for B is extra or not. In which functional dependency? A determine BC. So how we'll do that? What is the procedure for that? So to do that, we have a procedure. You'll see this. What is the procedure? The procedure is we have to find out the alpha closure without using this attribute in the right hand side part. If in the alpha closure we are getting this attribute, so we say that it is extra. Let's do that. So We'll find out A closure without using this B. So we assume that this B doesn't exist right now. So what is A closure? A closure, A will come. A is determining anything? Yes, A is determining C. Is C is determining anything? No, C is not determining anything. So it is not extra. Which one is not extra? B is not extra. Now go for A is extra or not. We'll check for A is extra or not in A, sorry, uh, C is extra or not in A determine B, C. C is extra or not, right? So for that, what we do is we'll check for A closure again without using C. So what is A closure? A closure, A will come. Now is determining anything? Yes, A is determining B. B is determining anything? Yes, B is determining C. So C is coming, right? If C is coming, then it means that it is extra. Which one is extra? C is extra. So what is my minimal cover right now? A determine B and B determines C. This is my minimal cover. And this is the answer. A determine B, B determines C. Right? So we have find out the extra in the left as well as we find out extra in the right. And this is the procedure that we have to follow. We have to go for the union first. Then we have to look for the extra in the left hand side. Then again, we have to go for the union. And then we have to go for the extra. And at last, also you can go for the union. So union will come every time. So here, if you'll see, here also we have uh, union operation. And after that, also we have a union operation. So you see, this is the first, second, and this is the third one. There's a fourth one, and this is the fifth one. So always we have to follow this particular procedure to find it out the canonical cover or the minimal cover. Both are same. So in the example, it may be asked like find out the minimal cover or find out the canonical cover. So you have to go for this particular procedure.